here from MIDANI Management, Hyderabad, and on behalf of MIDANI, our team, PowerTech, welcomes you all to our case study presentation. Here is a brief information about MIDANI. MIDANI is a Government of India organization under Ministry of Defence, established in 1973 with an objective to achieve self-reliance in making of critical alloys, superalloys, statutory alloys, and special steel for strategic application. We have 700 plus employees and we produce 500 different kind of grades under one roof. These are the 4 production areas: welding, forging, rolling, and wire drawing area. These are our major products and key customers of MIDANI. We have 2 manufacturing units, one is in Hyderabad and another is in Rohtak. Rohtak unit is especially for armory. This is the information about circle members. Myself is facilitator Ashish Gupta.
Myself M. Narendra, leader.
I am the Rajalakshmi, deputy leader.
Myself Mama Isha, member.
Myself B. Mulidhar, member.
Thank you. This is information about lean quality circle. Our circle name is PowerTech. We registered on 20th September 2023 and our working area for this case study is wire and wire drawing shop. So our case study belongs to wire drawing area, which plan to solve the problem by lean quality concept, which is demand. There are 3 ways for problem selection, but in this case the problem has been allotted by our management. This is the title of the problem: to minimize high processing time of wire drawing for high strength steel wires resulting in low productivity. And this is the approval letter given by the management to take up the case study. Why management has allotted the problem? To reduce the high processing cost and time and cost for the production for high strength steel wire. Also to minimize the high lead time for material delivery. This is a milestone chart we prepared to make the timeline to complete our project. We tentatively decided to complete the task within the 90 days of time. Step 1 is a defined. Our case study from the Barewa area, and these 2 equipments are related to our case study. First is the multi-head wire drawing machine and another is the bright annealing furnace. So before delving into the real case study, we will first understand what is the wire drawing process. Wire drawing is a metal working process used to produce the cross section of a wire by pulling the wire through single die or series of die. Through the animation we can see that after lubricating the wire passes through the die where the cross section gets reduced and sent for the further reduction. So this is a continuous process, and after certain stage the wire tensile strength becomes so high that the ductility of the wire will be low and the chances of wire breakage will be high. So we have to stop the process here and send the wire for further annealing for further elongation. Wire drawing is annealing is a process to reduce the material work hardening and to make the wire more ductile for reduction purpose and to ease the wire drawing process. This is the previous furnace which we are using for the annealing operation in shop floor. In our plant, we are dealing with the 2 different kind of grades. One is the soft material, another is the hard material. The input size is 4 mm and the output size is 1.2 mm. This is the animation video where we are showing how the wire drawing process happens for soft material from 4 dia to 3 dia. We have 3 sets of die, 3.5, 3.3, 3. With each reduction, the input size of 4 reduced to next size and ultimately it reaches to 3 mm size. And at this stage, we have to send the wire for annealing to remove the work hardening for further reduction. So the process involved for real production for soft steel from 4 to 1.2 dia is required 4 stages with 3 intermediate annealing cycles. The problem what we are facing is that when we are giving the same size of reduction to the high strength steel wire, the wiring breaking within the stage in the intermediate path, and we have to stop the process. We have to send the wire for re-annealing for further reduction. So this is the loss of production. To overcome the problem, we have modified our process sequence by reducing the cross-section reduction of the wire. Earlier, where we are going 4 to 3 mm, now we have to give only 4 to 3.5. Because of that, the number of stages increased from previous 4 to now 7, and the annealing operations also previously 4 to now 6. This is a comparative flow diagram for wire drawing for soft material and hard material. For soft material, 7 activities consuming 457 hours. And for hard material it requires 13 activities with 774 hours. The impact of the problem is we have to incur additional 1.2 lakhs of rupees for producing 1 ton of hard material as compared to soft material. Also it is hampering our dispatch activities, as well as we are not able to utilize our full machine efficiency.
Our objectives and goals are to reduce process time, to minimize wire breakage and to increase productivity.
Step 2 is measured. Here we followed the 4WNH method.
What is the problem?
High processing time of wire drawing for high strength steel wires.
Where is the problem?
Wire drawing machine.
When problem will occur?
During wire drawing of hard material.
Who is involved?
Operator shifting charge.
How it is effective?
Less productivity. Time consumed for producing 1 ton of soft material in 4 stages, drying the thickness from 4 mm to 1.2 mm, it takes 457 7 hours. Similarly, time consumed for producing 1 ton of hard material, drying the thickness from 4 mm to 1.2 mm in 7 stages, it takes 774 hours. This is the data collection of production from May 2023 to September 2023. Among these, the highest productivity we achieved in the month of July, that is 1.05 ton. Okay, to produce that 1.05 ton, it takes 774 hours. This is the least process time. It is taken as the target reference. We plan to reduce the complete cycle time by 30%, that is 540 hours. To analyze the problem, we conducted so many brainstorming sessions. Our team members gave some possible causes. Those possible causes are categorized into 4 groups. Those are machine, material, method, and when. By using this cause and effect diagram, we did YY analysis. For less productivity rate, in case of method, one of the possible causes is high processing time.
Why?
More number of passes.
Why?
Low reduction in passes.
Why?
High work hardened.
Why?
Insufficient annealing temperature. Another possible cause is more annealing process involved.
Why?
More number of passes.
Why?
Low reduction in passes.
Why?
High work hardened.
Why?
Insufficient annealing temperature. In case of material, possible causes frequent wire breakage.
Why?
Restriction in deformation.
Why?
Insufficient annealing temperature. Similarly, in machine and metal. After analyzing all these possible causes, we concluded the probable cause is insufficient annealing temperature. So, probable root cause is insufficient annealing temperature.
Here we did the gamma verification for cost validation, and for the probable cost, we analyzed that the furnace temperature was only going up to the 92 degrees Celsius. After discussion with the Material Department, R&D Department of MIDANI, they suggested that for high-strength steel wire, the furnace temperature should be more than 1100 to 1150 degrees Celsius, whereas our available furnace temperature was only 980 degrees Celsius. So this was the possible cause for this problem, and this we declared valid. So the root cause of this problem is insufficient annealing temperature. In the step 4, improve, we conducted many brainstorming sessions for development of solution, where our team members suggested 3 alternate solutions for the root cause. And we prepared the L matrix for comparative study to check the feasibility factors. What is the first alternate solution?
Procurement of new electrical furnace.
It requires more than 365 days for installation, and with the cost of investment 2 crore. As the time and money involved much high in this case, so the feasibility factor we found that very low, and this idea was dropped by our team member. What is the next?
Revamping of existing furnace.
It requires 60 days for installation, and the cost of investment is also 20 lakhs. But it is for that we have to stop our production, which hampers our production activities as well as dispatch activities. So this idea again declined by our team members. What is the next?
New indigenous furnace with improved heating design and enhanced thermal insulation.
This requires 60 days of installation with 40 lakhs of investment. This is possible because for that we need not to stop our production. Parallelly, we can build one new furnace and experiment it. So this idea was expected for our team members, and we continued with that. This is a proposed staging order for our new furnace, where we are showing the top view and the side view of the furnace, where the red part is the element part in the side walls and the bottom parts, and this is the dimension details of the furnace. This is the key specification of the furnace. So this is a resistive furnace, and this time we designed the furnace to reach up to 1150 degrees Celsius, as we have found in the gamma verification that this much temperature is required for annealing of high strength wire. And after that, we conducted meetings with all the stakeholders for finding out the probable forcing resistance. What is the first resistance?
Location of new furnace.
This resistance shown by the operation and safety department. For that, we conducted meetings with them, and we have mutually agreed for one place for positioning of the furnace. What is the next?
Requirement of extra power.
This is also given by operation and power station team. So we have discussed with the power station team and explained our exact power requirement. For that, they found the suitable source of power from their substation and ready to arrange the power for the furnace. So with their confirmation, we proceed for the trial implementation and take the approval for management for trial implementation. So we followed the PDA cycle to implement our project. In the P part, our objective was to install the new furnace to our shop floor by using in-house resources and buying necessary material with the help of management. In the do part, we developed design and drawing. We collected material and start fabrication and installation. This is the pictures we have captured during the erection time, where we have seen that the furnace insulation works completed in this picture, and the elements also placed onto the position in the side and bottom wall. This is the Cancer A1 material, which is very premium brand, which can go up to 1400 degrees Celsius of temperature. This is the power and control panels, which we have built indigenously inside with all the internal resources. And this is the pictures we have taken after erection work. We have placed the furnace to the position before taking the trial implementation. And this is the image of trial implementation. The red part is the element parts in the running condition, And the side part is the instrumentation panel showing the temperature 1150 of the furnace, which was our actual motive and objective to build the furnace.
And this is a new annealing furnace used for annealing process. This is the data collection during trial basis. Time consumed for producing 1 ton of hard material, it took 492 hours. And in the check part, trial checking of the performance and data collection done, and the system we found it okay and decided to management presentation for regular implementation of this project. And this is the approval letter for regular implementation of our project.
Step 4 is the control part. After regular implementation, we followed for the review and follow. Here, for standardization, we use 5W1H method and we incorporated 3 major points. For operators' knowledge, we introduced systematic operation procedure. To avoid any interruption in furnace during running, we introduced systematic maintenance plan. And for future reference, we developed drawing, we given drawing number and submitted into the design section.
Data collection during follow after regular implementation. Time consumed for producing 1 ton of hard material, 482 hours. Tangible benefits. Time taken to draw dia 42, dia 1.2 mm for production of 1 ton. Before modification 774 hours. After modification 482 hours only. Time saved 292 hours. Data collection improvement in ton. Before modification per month average tonnage 0.92 ton. After modification per month average 1.36 ton. Production increased 32%. Detailed flow diagram for hardware drawing. Before modification, total 13 activities are involved and time consuming 774 hours. After modification, only 9 activities are involved and time consuming 482 hours. Number of stages required to draw, while from dia 4 to dia 1.2 mm. Before modification, 7 stages are required. After modification, 5 stages enough. 2 stages eliminate.
Intangible benefits: improved customer satisfaction, work simplified, improved confidence level, pride over our own design and method.
Learning points: knowledge gained about lean QC tools and techniques, fabrication techniques, design of simple machines, and also computer knowledge.
This is a plan versus activity chart where we are showing that we almost completed our project within the as we have planned in the milestone chart. And the conclusion, we can proudly say that with the team efforts, we could finally achieve more than the set targets, and we totally reduced the time by 37%. Also, we improved the production by 32%. The achievement is we successfully supplied the finished wire to customer within the committed delivery time. We also saved 1.6 crore and 9 months of production by making the furnace indigenous. And this is the appreciation letter given by our management. This is the QC tools and techniques we use in our case study. This is our future project, issue of speed fluctuation in centerless grinding machine. And these are the reasons for that. We thank our management and senior officials and our HOD to help and support to prepare this and complete this case study. We also thank QC5 for giving this opportunity. Thank you.
Thank you.